Hi, my name is Colin Flanagan, and I'll be analyzing this Bollywood movie called Bagadira. As you can see, our hero is about to get totally creamed by a helicopter blade when his friend decides to drive a Jeep off a cliff and collide it in an inelastic collision to take out the helicopter. For part one, I'm going to be using measurements from the video to determine how fast it was going off the incline. So its initial speed. Part 1. How fast did the Jeep hit the incline? So if we pause the video here, I used a protractor to determine the angle at which the Jeep was launching itself off the crevice, and I used the main character as a 2-meter reference. Using the 2-meter reference, I determined the distance the helicopter was off the ground and the distance between the helicopter and the Jeep. A ½ inch on my screen corresponded with 2 meters. 4½ inches corresponded with 18 meters. That's how I did the measurements. As it flies through the air, we stop the video right here, right as it collides. We can see that the Jeep was at the apex of its jump, which means that all the velocity was in the horizontal direction, and so the y velocity at the end of the flight is 0. It's all in the x. So we're going to use kinematic equations to figure out how fast the Jeep is going when it left the ramp. Delta y is 3.5 meters, and that's how high above the helicopter was above the ground. We don't know the initial y velocity. We're going to be solving for that. The final y velocity is 0 meters per second, because it's at the apex of its jump. Negative 9.8 meters for acceleration, because that's gravity. We can use this equation to solve for the initial velocity without the time value. When all is said and done, we come to a final y velocity of 8.28 meters per second. 20 degrees is the initial value that we had for the Jeep's jump. So part 2, is 18 meters away reasonable? Since we know how fast it was going initially, we want to check if 18 meters away is accurate for how fast the Jeep was going. Let's see if the movie makers got it right. First, we need to calculate the initial x velocity. Using the same triangle as before, we instead find the cosine of the angle to determine the x. When all is said and done, we find that the x is 22.75 meters per second. We know the x velocity. So now that we know the variables from part 1 and 2, the y and the x values. So now but before we can determine the delta x, we need to know the t. This kinematic equation allows us to solve for t, which we find is 0.845 seconds. The math tells us that the Jeep would have flown 19 meters, which means that the movie makers actually got it right, or pretty close. They're only off by 6.8%, which is impressive. For part 3, this is the calculation we need to know the total momentum at the start versus at the end. We can watch our hero be saved by his friend again. For this calculation, we're going to need to know the momentum before and after. I found these masses by looking up a standard Jeep from the Army and a standard police helicopter, since they seemed like they were around the same size. See that nice inelastic collision? Afterwards, the masses will be summed because it's now one object. The new mass times whatever velocity we find. So here we have our initial momentums, and the equation shows that momentum is conserved afterwards. The total momentum would be that of the Jeep plus the helicopter. All this should be equal to the momentum of the final mass and whatever the final velocity is. And after doing the math, we find out that the final velocity is 11.26 meters per second. Thanks for watching.